And welcome to the Daily Space Weather, folks. We literally have too many things to cover today, so pardon the pacing if we blast through like maniacs. First of all, we're looking at the sun at 171 angstroms, and we see all kinds of filamentary behavior all around the limbs, and a small bit of activity kicking off north of the center disk there. In fact, that looks like a little bit of plasma filamentary behavior as well. Some interesting stuff going on in the northwest still, as well as down here in the southeast. And we got close-ups of that area. Here's a close-up on HelioViewer. And so that's a super interesting little area there. Great view of that little looped bit of ionized iron. And we're also going to look at 304 angstroms of the same area. First, the whole solar disk. And again, filaments all around the solar disk, folks. And keep in mind, you don't need to see X-ray flares to see huge coronal mass ejections. And there's a whole bunch of plasma dancing around down there. And next we'll look at that same region here in 304 angstroms. And I would note the way different ionized nuclei react completely differently to the solar magnetic fields. And man, oh man, we've got way too much stuff to cover. Here's the magnetic fields plus 171 angstroms, and you can see nothing resembling a sunspot in the Earth-facing region. And if we see anything form today, it'll be around here. A little bright spot forming there. And there could be a filament eruption happening right as we do the show, folks. That's just the way it works. Here's the GOES X-ray flux. No flaring has been occurring. 10.7 centimeter radial flux is at 71. KP index is at 2. Real-time solar wind showing us a shifting phi angle. Once again shifting around as we did show prep. BTBZ is fairly stable though. A measurement of the sun's field. Phi angle, a measurement of the orientation of the incoming solar wind particles. Completely different. BTBZ measures the sun's fields. Phi angle measures the orientation of the plasma in the solar wind. Solar wind density 4.5 protons per cubic centimeter. Solar wind speed 395 kilometers a second. There's the data from ACE, looking corroborative. Next, we've got 4 hours of magnetosphere movies, looking at the magnetohydrodynamic pressure. And it's pretty steady here. We're going to let it play, as we do every day. And we try to keep it lighthearted over here no matter how disastrous things get. And they're not getting very disastrous right now. Everything's pretty calm. There are the ground geospace magnetic perturbations. And we see a little bit of induced magnetism there. Is the magnetism coming out of the Earth? Is it coming out of the sun? Or is it some sort of an interaction between the two that causes it to be the way it is? I know what Ben Davidson's answer is. Do you? Anyway, there's 4 hours of magnetic perturbations. Next, we'll look at the total electron content, as we've been seeing a little higher levels of electrons as forecasted. Anyway, there's the total electron content. And when you see those orange blobs there, folks, if you're around the equator, around noon, for instance, you can expect to see pretty large GPS errors of up to something like 50 meters, I believe, at those levels. And we're talking about around 44 electrons 10 to the 18th per meter squared. And so a little higher electron content here. Wouldn't be surprised to see this go back into the alert level in a couple hours today. And there's the data on the electron content. The GOES electron flux is taken around the F2 ionosphere layer, which is why we look at this slide after those slides. There's the F2 ionosphere, or the F ionosphere, where you see the red blobs. That would be an F nothing layer. And it's looking a little bit less anomalous than it has in the past month or so, especially in the South Pacific off the west coast of South America. Here's the latest image. Geez, we have so much stuff to do yet. I have about 94 more tabs open. Here's the GOES magnetometers, and its continued irregularities here are caused by the local yellow dwarf's environment, the heliosphere, the current sheet, the heliospheric current sheet. Keep in mind this data is 1 hour and 22 minutes old, and everything is almost entirely South Pole polarity, shown here in red. And you see that little area popping up? That is a perfect example of the way you can see the field get pulled back by a sunspot. That sunspot that's setting on the southwest is what's causing that. And if it degrades, and it probably will, we will not see the North Pole shine through and charge up that part of the current sheet. It'll just pop back the way it was. That's my forecast. Next, we'll look at earthquakes. And we see a deep one just about 24 hours ago. By the way, it's 4:52. We see a deep one just about 24 hours ago at 4.4 magnitude, 505 kilometers depth, in the deep quake capital of the world, Oceania, north of New Zealand, near Fiji. And I'm just going to scroll up the list here. Pardon the speed at which I do it. This website is earthquake.usgs.gov. You can look up all the data yourself. Here's a fairly deep quake at nearly 100 kilometers at a 4.6 magnitude at the Philippines. And we do see an uptick in volcanic activity. Once again, a new volcano on the list. We'll tell you about it in a minute. First, another deep quake on western South America, which remains my favorite spot for a large earthquake, as we really still are in a drought of 7 magnitude plus earthquakes, folks. So there's another very deep quake near Fiji. That one a little farther south, 4.6 magnitude, 546 kilometers depth. And we see some Hawaiian quakes kicking off also. And here's one while we did show prep, a deep quake at Alaska. And we've seen several of them there, all at small magnitudes. That one's at 132 kilometers depth. Here's Mayon volcano. I've put another favorite here onto windy.com just to show our viewers where Mayon volcano is located. Don't get within 6 kilometers of it, as it's been raised to a level 2 alert. And folks are being warned that it could explode at any time. So if you're going to the Philippines, don't pitch a tent at the base of Mayon. Now we're going to just let this advance about 24 hours here. The GFS model on windy.com. Seriously dry air over the North Atlantic. And we'll pause this at about 12 noon Universal Time. 13 Universal Time there, otherwise known as Greenwich Mean Time. Anyway, that's where we expect pressure to be at that point. And here's part of the warning about Mount Mayon volcano in the Philippines. It's strongly recommended that entry into the 6 kilometer radius should be strictly prohibited. The public is reminded that sudden explosions, lava collapse, pyroclastic density currents, or PDCs, whatever that is, and ashfall can occur without warning and threaten areas on the upper middle slopes. So stay away. Stay 6 kilometers away or more. Let's see what other volcanoes have been erupting. Mount Aso continuing to explode. Flight level 6,000 there. Sakurajima, flight level 8,000 there. Stay away from Mount Mayon if you know what's good for you. Don't fly your ultralight John Denver-style aircraft over it. Mount Takono exploding, flight level 7,000 there. Popocatépetl exploding, flight level 19,000 there. Fuego exploding, 14,000. Sangay exploding, 22,000. Revenador exploding, 16,000. Sabancaya, not sure, don't try to pole vault it. Piton de la Fournaise at La Réunion, a French island, has now started to erupt without ash cloud production. So if you're on vacation at La Réunion, a very popular honeymoon location, stay away from the volcano. We've upgraded the coronavirus section of smashomash.com/forum, the section on coronavirus, as there's a long zero hedge article that we've picked up here. Death rate up to 5% according to a Wuhan doctor. So keep in mind, folks, this has got a long gestation period, and the virus is able to stay alive for quite a long time, over a week on surfaces. So, I mean, we are expecting this to be highly underreported also, as there are so many people quarantined in China who are still unable to get to the hospital, most likely. Although some of the infrastructure has come back up today. There are stories all over the internet about that. We're not going to spend too much time on it. Here's the graph on the Johns Hopkins site. Total deaths up to 900, so approaching 1,000 deaths. It has surpassed SARS now for deaths, and over 40,000 confirmed cases. Let's go back to geospace type things like lightning. And there's a bunch of it striking right now. Clarksdale. Hey, Clarksdale, there's thunder rolling in. Next time you hear it, check out lightningmaps.org. Impress your friends, impress your foes by predicting when thunder will arrive before it arrives. Looks like we've got some old data from yesterday. There's the current U.S. radar map. And just what we didn't order, more rain. Not a fan, not a fan. Here's a water vapor map. And yeah, I always like to know what's going on above my head. What about you? Check out this interesting convergence zone over Florida. Sorry I didn't get back to you, Mothra. I hope you enjoy the Vietnamese food. And yeah, been too busy, a little bit too busy. Anyway, interesting zone of convergence there. A bunch of dry air pushing through into Florida today. Should have clear skies down there. Please leave a comment if you're in Florida. Please leave a comment if you know what Florida is. And here's the Euro map of water vapor. And let me speed that up, as I have no patience for slow maps. Full speed. I believe that's 3 hours of data there, folks. And I guess I got to add this to the link library one of these days. Interesting convergence here off of the west coast of Africa. We're not zooming in. You can forget it. Next, we'll look at nullschool.net, at the jet streams. There's the eastern world. Here's the west. By the way, have you pressed like and subscribe on YouTube? We're almost at 1,500 subscribers. Oh my goodness gracious. Hundreds and hundreds of daily space weather videos. And yesterday we did appear in a lengthy session on the Electric View. If you haven't subscribed to Electric View, go over there and give a shout out. Tell them smAsho sent you. And yesterday's video about grand unified theory. We also put up a video yesterday featuring Eugene Bagashov, theoretical physicist, who explained kind of the mainstream, the sort of acceptable theories of everything, So if you haven't watched that, check it out. Here's a tidbit.
The famous dark matter problem.
Sure.
That. It's not general relativity. People just use Newtonian dynamics. So general relativity is supposed to be needed when you have strong gravitational fields. And you might say, well, the galaxy has a strong gravitational field, but this is not the case. I mean, if you look at, if you calculate the forces that act on stars from gravitation, from galaxy, they are very small forces. If you calculate the accelerations, they're just super small.
And that's largely because of the distance and the distance at which gravity is able to impart forces upon things.
Exactly. It's mostly because of distance. So, I mean, if the sun orbits the galaxy at like 50 or something like that, 50,000 light years away from the center, or maybe 30, or I don't know.
Something like that, but yeah.
Yes.
On that scale.
But this is a very long distance. So the gravitational acceleration towards the center is very small.
And we, of course, linked to that below the video, in case you haven't seen it yet. I have a feeling it'll be fairly popular. And if you want to read more about the theory of everything that we were talking about, basically what we're talking about is quantum field theory, general relativity, and Newtonian dynamics, as when you are in certain aspects of the universe, measuring things in one way is very beneficial versus measuring things in another way, and they start to break down. Here's one of the images that Eugene was kind enough to share. He translated this from Cyrillic Russian out of a textbook that he has. And so now you can add this concept, and it's a great concept. You've got very low kinetic energies down here in the lower left, quantum field theory straight up here, and then Newtonian physics out here on the right. And we're putting everything into one video today. So do you follow us on other social media, alt-tech like minds.com? We really need tokens. Get an account over there and send us some tokens, folks. We're down to less than 1 token, and we can't boost our content anymore unless folks send us some tokens. So get a minds.com account. Head to minds.com/smAsho. We are also on BitChute, just in case the YouTube channel gets suddenly deleted with no warning or explanation. We're also funded by Patreon, so please consider becoming a patron and helping to enhance the coverage and ensure that these videos will continue to come out. Thanks, Smash Team. We've got bonus features out the yin-yang. We got no time to spend on the colorized magnetogram. So in lieu of that, we're going to show you the 48-hour video of the local yellow dwarf in 193 angstroms as we see that large coronal hole in the north, as well as some more diffuse ones along the equator, about to be into an Earth effective magnetic zone. And let's move on to lots more stuff. So this is basically the cosmology segment. We're just going to dovetail this in for today. And smAsho staff, if you want to make clips of every little segment of the video, feel free. Super excited about the Solar Orbiter, which has finally launched last night, and I believe it's all systems go. Here's an article from space.com about it, and we'll just show you a little clip of the launch here to tease you and get you to click the links.
Of our solar orbiter and international collaboration to give us new images and a better understanding of our life-giving star.
So it's going to be super exciting, folks, and while there is some pessimism about the mission's parameters and its declination to the sun and so on, it should still be providing some data in addition to the Parker Solar Probe. So let's talk about where things are located. There's where they are right now. I like to use the planetstoday.com for its great solar system chart. And there's where things will be in a week. Mercury is swinging around fast, and Venus is coming up strong, like onions. Next, we'll look at a star chart, as I'm always interested in what's going on above my head. Looks like we've got the moon up there, as well as Mars on the rise. There's a red planet on the rise. If you've got a low horizon, take a telescope shot. We're skipping cosmic rays today, but we always leave links in the description. And if you're wondering what the music that we played at the beginning of the video was, it was You, Me, Us from 2009 or possibly 2008, which you can stream for free or purchase and add to your MP3 collection for the low, low price of 99 cents. Original music at soundclick.com. We have made the web whiteboard public. It's only going to be up for another 12 days as we don't pay for this. And so some interesting graphics there if you'd like to share them or add your own graffiti, feel free. Here's your daily sounds of the solar wind. Oh yeah, that's a normal solar wind. Next we're going to play a solar wind storm. Now listen to a solar wind storm. Freaky, right? All right. Did you watch our cosmology section where we talk about neutron star RxJ1855635-3754? Well, it's traveling at a speed of about 241,000 miles per hour. Here's a tidbit. Cygnus A radio galaxy t-shirt. Interesting neutron star, to say the least. And if you think comets are fast, well, comets are pretty fast. How fast do you think that neutron star is moving? As you can see, it was located over here on October 6, 19... Anyway, watch that video if you haven't. We've linked it below this one as well. And we've updated our The Most section in the cosmology thread on the smashomash.com/forum to include an image of this oddity. Let's talk about gravity. It's possible that gravity alone is responsible for all of the motions in space. Survey said...